So while we're preparing for next talk, I'll introduce the academic track a bit. So the academic track has been around since Saturn 2018. And Marco Mignani was like the chair for all these years. And I joined him since 2019. And we had many people collaborating with us. And the idea is that there's a lot of OpenStreetMap research happening in academic spheres and not always interacting with the community. So we wanted to create like this kind of stage for the academic world to interact with the community and vice versa. So we're having talks, enlightening talks and posters since then. Last year, we renamed the academic track as OSM Science, which is also like a term as representing a research field that we're trying to promote. But the reason was a bit technical. We didn't have a global SOCM last year, so we wanted to have a specific name, and the academic track happened as part of the European SOCM. Okay, so we wanted to have like this brand name saying this is like the global meeting of OpenStreetMap research and researchers. Wherever it's happening, part of the global state of the map, part of the local or regional state of the map. Yeah, so we're very happy to have it again part of the global state of the map. And I'll just say it's kind of well separated into three parts. Now we're in the morning, we're in the data-oriented part. So we heard about data-driven process to support mapping. We're going to hear now about data quality. Later we're going to hear talk about how to use the data for other purposes. Then we'll have a section about contribution processes, mostly focusing on corporate editors. Very interesting and volatile topic. And towards the end of the day, we'll switch to like the social context and social processes within OpenStreetMap. So yeah, that's for introducing the track / OSM Science. And now we'll move on to our next talk by Wang Xu from Heidelberg University, GI Science Research Group at Heidelberg University / from the Technical University of Munich. And she's gonna tell us about the new matrix, quality matrix they are developing there that relates to like the specificities of the road driving laws and so on. Go ahead, Wang Xu, thank you.
Thank you, yeah, for the introduction. So again, my name is Wang Xu. I'm affiliated to both TU Munich and also Heidelberg University, and I locate in Heidelberg and work together with, if you went to the workshop yesterday, then I work together with Highgate people. So this is about projects that focus on road data quality in general. And it started a few months ago, so it's still at its very early stage, and any comments and feedback would be very welcome. Today, I just focus on the attributes. So this talk is about assessing the attribute accuracy and logical consistency of road data in OpenStreetMap. Okay. Yeah, why do we do this? Because as you are all mappers and you are contributors, because of the crowdsourced nature of OpenStreetMap, sometimes that I know like mappers did a lot of education to people, try to follow the guidelines, but still there are data quality issues, and we want to assess the data quality and then develop metrics to assess that. And later, maybe for different use cases, you could know if you could use OSM data. And in the end, we could also provide or propose ways to improve the data quality of OSM. And normally, there are two major groups of indicators. One is extrinsic, which means you compare OpenStreetMap data with a reference data set that you consider the quality as good enough. Another big group is about intrinsic data quality indicators. That is about that you look into the OpenStreetMap data itself and try to approximate data quality from the data itself. Yeah, there is no universal solution to everything. So mostly for those data quality measures, it's about fitness for use. You have different use cases, and for different use cases, probably the data quality varies. For example, we focus on navigation, and for a car driving scenario would be different with wheelchair users if you look into the attributes. Yeah, so why we start with car driving, because it's kind of like the most common use case, and we are interested in navigation in general. What I'm going to talk about is about attribute accuracy. That's kind of like how correct the attributes are, and also logical consistency, which it's about the coherent logic of the road network. And before we look into that, we want to know what are the important attributes for car driving. And for that, we conducted an expert workshop, which is a focus group study with experts from automotive domain. And so it's kind of like we sit together, and there are more or less like 2 or 3 guiding questions. That's what are the important attributes of car driving, and what are their levels of importance and why. And in the end, we somehow aggregate all the discussion together, and then we came up with this table that you could see here. So we divide that into 2 main use, let's say. One is routing, and another one is about providing guidance to the drivers. And we differentiate that into 3 different levels, which is basic requirements that include road class, which in OSM it can be translated into the highway, and then different values of highway or different types of highway. Speed limit, of course, is important, and also travel direction. So in OSM, if you don't mark it, then it's by default on both directions. But if it's a one-way street, then you mark the travel direction, or if it has like several lanes, then you also mark the travel direction there. And road surface data, since we focus on car driving, we consider automobile access. And then we consider if the data, after fulfilling the basic requirements, if the data has higher quality than if they have attributes on whether it is urban area or rural area, and focus also on turn restrictions. So here there's also continued turn restrictions. The difference is for turn restrictions, we consider only 2 links or 2 ways, and for continued one is above 3 ways connected. And looking into the guidance side, there are lane information. That's, for example, there are different lanes. One is like you can turn right, or you can turn left, and then you can go straight and then turn right. And whether this information are available, if they are available, we could prepare the drivers. Maybe you drive to the left. If you want to turn left, you drive to the left turning lane first, and then later it's easier to turn. And also whether the railway crossings or pedestrian crossings are available in the data. And then the next level is about providing high confidence. That's, for example, controlled access, and in some highways, they kind of regulate this ingress and egress, and are those data also available in OpenStreetMap? So after looking into that, we started to look into, at the current stage, we only looked into this basic requirements, how complete the attributes are. So for that, we just consider binary, like whether the information is available or whether this attribute is available there. And for now, we consider equal weight. Then we somehow calculated the attribute completeness of each segment by the average of all the attributes. And then if you give an area or a bounding box, then the area, the average of the, then the attribute completeness of that area is the average of all the road segments. And here you can, sorry, it's not so, yeah, not so visible. Anyway, so that's city center area in Munich, and where the tag is actually where TU Munich is located on Akisstrasse. Yeah, as you can see, the attribute completeness, just considering the basic requirement, is quite complete in Munich. And then we move on to attribute accuracy. We focused on speed limits. As we locate in Germany, we start from Germany. What we look at is the default speed limit, and there is an OSM wiki page on this default speed limit aggregated by contributors worldwide, I guess. And what we did now is we check the max speed or the speed limit against the country's specific traffic laws. And yeah, as I said, they are based on the community knowledge in OSM Wiki. And then after the check-in, the inaccuracy rate is considered as the length of the segments with questionable max speed. So we detect some cases. We are actually not sure if they are inaccurate or accurate, so we mark them as questionable cases, and then divided by the total length of the segments that has this attribute. And that's also what we tested in Munich. And from there, what we detected is kind of, for example, a residential road with a max speed of 60, which is more or less clear that's quite inaccurate. But and sorry, the resolution is not so good, but there are also cases that probably local knowledge is needed. For example, there are motorway links that has a max speed of 50, and based on German traffic law, if it's not urban area, then it has to have a minimum speed limit of 60. And then after our rules, we check it's 50, but actually we talk with people who are in this area. They said it's actually in urban area. I put that in later discussion, but we can also discuss it now. So then, because for now we just check the text, whether the urban information is available in the text. But in the next step, we think maybe we can also check the geometry. So maybe we buffer the zone, and if it's kind of like in an urban zone, then we also take that into consideration and group that into the urban area, other than just simply checking the text. And now we move on to logical inconsistency. So there are some kind of inconsistency cases or checks that we did, and they are very much inspired by this Keep Right tool, and also from the OSM France community. There's also more, this tool, and then so those logic are very much inspired there. So first one is about highway value inconsistency. So in a road network, or at least in Germany, on a way, for example, you have a motorway and it cannot be directly connected to a residential road. I was told that in other areas in the world, this probably can be the case. I'm not sure, maybe if you know, could tell me, but that's at least not the case, for example, in Germany. So we did this check, and also motorways can only be connected to motorway or motorway link. Then we also did this check, and it's called leaking motorways. And then some link connection needs to be connected at least once to its corresponding highway type. We also did such kind of check, and also major roads should lead to somewhere, cannot be dead end, and also same as one way. So for now, that's all the logical consistency checks we did. And we also have an aggregated indicator, which is called logical inconsistency, which is basically the length of all the affected road segments, like considering all those checks divided by the total length. And that's kind of what we did for this bounding box area in Munich. And I think the like it's quite easy to spot the current problem. Yeah, I can also move on to the next sorry. Yeah, so maybe I stay here. So currently, as you can see, there are a lot of things marked at the bounding box area, which is very much due to the current data handling. So for now, because we just started and we want to test those methods, what we did is we retrieve data from Awesome API, and then we get the data, we use Python, so we put them into a geodata frame, and we do not consider other data. So that's the data we retrieved. And for those bounding box area, there's kind of an artificial cut. And for considering the stat and all the things, you consider this connectivity. Actually, they are connected to somewhere outside the bounding box, but they're just not considered. If you just have this piece of data, they're not considered. So for the next step, we're thinking about link it to a database, or we use a new file format from Higit that they presented yesterday in the workshop, that we have a bigger area and then we buffer around the requested bounding box. Then for this connectivity check, we also consider this buffered zone so that there is no artificial check to reduce the false positives. And I already talked about this exceptional cases for split limit. So there are some exceptional cases, or there are cases that just like urban tag is somehow missing. We could consider, consider the geometry to also buffer the area to know whether it is urban or rural. And also, so currently our indicator, they are aggregated by individual measures, which provides varying levels of detail. So if you just want to know whether I can use the data, then you get the aggregated result. If it's quite high, then you think, okay, the data is usable. And if it's just very low, or the inconsistent rate is very high, then maybe you could think about using different data set, or inform the community that, okay, somehow I want to use it. Could you, I don't know, organize a mapathon or something to make the data, to correct the data or make the data more complete. But if once you decide to use the data, then I think it's more worthwhile to look into individual cases. What are the problems? And then before use, you might want to think about to fix the problem. And also in this way, this indicator, they are also very flexible. If we want to add further kind of checks into it, they offer this flexibility to adding new things later. And the next steps, so I introduced attribute completeness first. So for the next step, we want to consider the other levels, like also high quality and high confidence, looking into like those guidance things there. And then we also want to do a case study. For now, we just focus on Germany. So maybe a case study comparing different German cities with different social demographic indicators, and see whether they have like some correlation, or they have some influence on the data quality. And for split limit, thanks to the community, we already have an aggregated page. So we want to scale it up to the global level by crawling the data from basically the wiki page, and then set all those rules automatically, and then check split limit against that. And as there are always exceptional cases, that's my plea also to the community. So maybe we also think about like putting another OSM wiki page, or linking to this original default split limit page if you see any exceptional cases that are not fulfilling the default rule. So normally this default split limit is more, let's say, coarse than the real cases. Normally they have this signpost there, and normally if probably an urban route, they say, okay, maximum 50, but they have specific route with maybe 30 or 20. They are like mostly cores, but there are also exceptional cases like we detected. So it would be nice to have the community also collect those exceptional cases data, and then later if they are aggregated also on a wiki page, then we could easily access to it and also use it to check those exceptional cases. And yeah, with this, I would like to say thank you.
Thank you, Wangshu. We'll start with questions from the audience. Okay. Thinking of your, you actually want to make it global eventually. And I'm a bit worried because we know that like the classification of highways in OpenStreetMap doesn't overlap neatly with each national kind of classification. And usually speed limits relate to the specific national classifications. So have you ever like given some consideration to that, that you cannot just based on the wiki page expect this kind of consistency since the basic classification is not overlapping entirely?
We thought about this kind of mapping, and also we also talk about this for Germany, but for the worldwide, we actually haven't looked into it, but it's something definitely worth looking into it. And also, we also, because we very much focus on car driving now, and we are thinking about different standards. So there is this navigation data standard also from the car driving, and what they did was they put different roads into different classes to make like countrywide driving possible. So we're also thinking about maybe looking into that, and then how to have this mapping from OSM classes to the road classes in different countries, and also how like basically learn from that. But that's not yet started, but it's just a thought. Yeah.
Any questions from the crowd? Well, I was thinking like knowing the German highways, usually when you come close to an urban area, suddenly there's a speed limit, where in like in other areas, and I'm not sure if it falls within like the urban category. So I was like just thinking, you talked about using geometry and other text, but maybe you can use like some kind of machine learning processes or AI to kind of try to understand what to expect, and maybe that would help solve in certain cases. So just an idea more than a question.
Thank you.
How much time is necessary to process, for example, all of Germany? And how it is possible actually to provide, for example, like kind of Serbia to process that country?
Yeah, so just the question was about processing time for at the national level for different countries.
Yeah, so sorry, so far I haven't tried it, so it's really an initial try. I can just say for currently for Munich area that we chose, I think it's for actually the major part is about downloading the data, and after the data downloaded, I didn't calculate the time, but the rest is rather okay. So the downloading is the major problem. That's also why, I haven't tried with whole Germany. Yeah, but I think even for the downloading, I don't know, several minutes or yeah.
Okay. Is the code available on a GitHub repository? Or?
So far not, but I will make it available. Yeah.
Okay, great. So if no more questions, thank you. Yeah.